Okay, on this example, we are given the apothem. So we know our apothem is 6. So if we're trying to find the area, we have to figure out what each side length is, because that will help us calculate the perimeter. So just looking at this figure, you might not see a triangle, but we love triangles. We love right triangles. We can use trig, we can use Pythag, we can use special right. We always want to try and create a triangle. So I'm going to draw my radius from my center to my vertex. That's my radius. So I have just created this right triangle because I know my apothem will always be perpendicular to my side. So I need to find my central angle. I need to find this angle up here. So remember, I'm going to do 360 divided by the number of sides, which is 6. So 60 degrees is the central angle. Then I'm going to divide that by 2, and that gives me 30 degrees. So this little angle up here is 30 degrees, half of 60. Oh my gosh. Oh my gosh. It's a special right triangle. A 30, 60, 90 special right triangle. I'm going to take that right triangle and redraw it a little bit bigger, just so it's a little bit easier to see. This angle up here is 30, this angle down here is 60, and this is 6. Okay, so I'm trying to figure out the side length. So I need this little nugget right here. So I need this side. I have the side across from the 60. I'm trying to get the side across from the 30. So I'm going to divide by root 3. 6 divided by root 3. I'm going to do my fancy one, root 3 over root 3. Gives me 6 root 3 over 3, which is 2 root 3. So this little nugget is 2 root 3, which I'm just going to double it to get the whole side length, which is 4 root 3. So each side of this hexagon is 4 root 3, which means the perimeter is going to be 6 times that side length. 6 times 4 root 3, which is 24 root 3. So the area of this hexagon is going to be 1/2 times the apothem, which is 6, times the perimeter, which is 24 root 3. And so half of 6 is 3 times 24 is 72 root 3. In simplest radical form, feet squared. And then if it had asked me to round to the nearest tenth or something like that, I would just type that in my calculator. So pretend like I had told you ahead of time, put this answer in simplest radical form. So the kicker is, I knew the apothem, I created a right triangle, I found the central angle and then divided it by 2 to get this little top angle. It turned out to be a 30, 60, 90 special right triangle. I found this missing side of this triangle, which I then doubled to get the missing side of the hexagon. Then once I had the side length, then I could find the perimeter, and then I just go plug everything into the formula.